Hello and welcome to our Future of Work webinar. I'm Rick Kelman, the Director of Product Management at FileMaker, and I'm joined by our presenter, Bonnie Walker, as well as our Product Manager for FileMaker Clients, Robert Halsey, who's joined us for Q&A after Bonnie's presentation. On the next slide, you'll see just some housekeeping before we get started. For best experience with the webinar, we strongly recommend that you participate with at least a broadband connection. If you have any problems or require online assistance at any time, please contact LogMeIn Technical Support. The number is 888-259-8414. And again, that number is 888-259-8414. Now, we will have an opportunity to ask questions, and you'll see that on the next slide, the information on how to quickly do that. You go into the control panel. You click on the question section, you type in your question and click send, and we'll cover as many questions as time allows at the end of our presentation. So on the next slide here, you really see wrapped up in a nutshell FileMaker's products, platform, and what our company strives to deliver on, and that is making powerful technologies accessible to everyone, which is, quite a laudable thing to do, but we strive to do that. On the next slide, you see here something that at our annual developers conference in Dallas, Texas, this past August, we introduced our new workplace innovation platform category that helps us to better express the essence of what FileMaker is about. And this is the slide that I shared to help articulate FileMaker's DNA, or its essence, if you will. And that's making the complex simple, so taking technologies and making it accessible to people that need to leverage them to help solve their unique workplace problems, and as close as possible to the person who has those problems. So it's either themselves using our product or working closely with one of our FBA members, but creating something wholly custom and bespoke for their business. And then finally, always looking to embrace new technology, but making it accessible to that person that we really focus on. On the next slide here, you see a simplified version when I talk about the workplace innovation platform, especially in the integration domain, I typically refer to it as emerging and converging technologies, and especially as it relates to artificial intelligence, machine learning, and the Internet of Things. There's the slide. Thank you very much. Now, there's a strong interrelationship amongst these technologies, especially when combined together. So when you combine artificial intelligence, or more specifically machine learning and the Internet of Things, along with what we'll see in today's webinars, robotics, you can do some very powerful and interesting things. Using the FileMaker Workplace Innovation Platform, you'll see how one of our talented developers has combined these technologies with several others that Bonnie will talk about into a cohesive custom solution designed to help make the world just a little bit better place. And so with that, I'd like to introduce Bonnie Walker. It's my pleasure to introduce Bonnie, and she's the president of dbVisionWorks and FunDaLogic Robotics, to share what she's been working on in this regard to these technologies over the past few years. So Bonnie, take it away. And can you unmute if you're muted, Bonnie?
Great.
Okay, we can hear you now.
Thank you, Rick. Hello, my name is Bonnie Walker. I worked for Yamaha Corporation of America, where all of us in the music education department used Macs. The programs we used to build apps and compile data were HyperCard, HyperMIDI, and FileMaker. This is how it all started for me back in 1987. I was sold from the beginning, and I loved using these applications and saw endless possibilities to help businesses solve problems. It was not until 1993 when I started my company, dbVisionWorks, that I switched to FileMaker exclusively and have never looked back. Since then, I've been an advocate for all things FileMaker. Music is also a big part of my life and family. My wonderful husband, Doug, a musician, recording engineer, and my best friend, a daughter that always surprises me as to what she can and will do, also a musician and a music teacher who is now homeschooling my granddaughter and working with me on the project we'll be discussing today. My beautiful dancing, singing, special needs granddaughter is my inspiration for much of what we will see today. I'm honored to have this opportunity to share what I love about FileMaker and how I'm using it. Additionally, I would like to thank a couple of my colleagues in the FileMaker community, Catherine Russell, Ray Colligan, for working tirelessly with me to help find solutions. Luke Rochester, Wim DeCourt, Johan Hedman, and many others for their support and encouragement. Today, I'd like to talk to you about the ARIES project, a tool for children within the autism spectrum. Currently, autism is the fastest growing developmental disorder in the United States. We've addressed this concern with an application specifically for these special kids. The ARIES project has been launched in an early childhood education program with an emphasis on autism in a New Jersey school that has a large program working with autistic children. The project uses technology such as AI, artificial intelligence, machine learning, Google Talk, Google Dialogue, and Watson APIs, and many, many programming languages. Now, let me give some facts on autism. Autism is referred to as autism spectrum disorder, or ASD, and is a developmental disability that can cause a range of mild to severe social, communication, and behavioral changes. Most people with autism look like other people, but their behavior, social skills, and communication are markedly different than people without the disorder. Autism is the fastest growing serious developmental disability in the US. While there is no medical detection or known cure for autism, thousands of children have shown significant improvement resulting from early diagnosis and use of effective interventions. Based on the 6 degrees of separation theory and the staggering growing statistics of people on the spectrum, it's fairly safe to say that each of us knows and/or interacts with adults and children with autism. The diagnosis of children with ASD has risen so dramatically, as you can see on the chart, where in 2018, 1 in 59 children are on the spectrum. By 2025, it's estimated that 50% of all children will have a diagnosis of autism. Research has shown that symptoms may decrease radically for those who receive intensive early intervention. This chart indicates initial diagnosis of children with ASD. Notice that 40% of these kids are not getting diagnosed until the age of 6 and over. That's school age. People with autism can learn coping skills to help them manage their difficulties and even build on their unique strengths. Any form of autism can be overwhelming to the entire family. Even high-functioning autism can be challenging. Families may be under a great deal of stress, and they need all the non-judgmental help they can get from friends, extended family, and service providers. One of the primary service providers is our public school system. At schools around the world, social robots are one of the methods used for assisting students with autism in the classroom. Autistic students are often confused or even intimidated by communicating with other people. Nonverbal cues and facial expressions that other people automatically pick up on can be very difficult to comprehend for some autistic people. One robot that has been particularly useful in educating and assisting autistic children is the Now robot. This fully programmable robot is multi-interactive, predictable, engaging, and tireless. He's been assisting autistic children with tailor-made lessons as well as social cues, and he helps build bridges between the children and people around them. Now keeps the risk of overstimulation to a minimum and does not confuse the students with complex facial expressions or body language. He helps reduce anxiety and is easy to understand, offering continuous encouragement and tirelessly repeating instruction. Now easily gains a child's trust. Social robots facilitate learning, engage students, and can gather information about the student's progress. Instructors are continually looking for methods to assist kids with ASD cope with their surroundings, and social robots are one of those methods. Social robots have been proven performers in assisting with teaching activities such as vocabulary words, motor imitation skills, and social skills through games, stories, and songs. So, enter the ARIES project, a fully customizable program for teachers to create behaviors in the classroom to work on skill sets necessary to help autistic children. An example of this is a vocabulary behavior, where teachers choose among other parameters, categories, and then words within the categories. Once the behavior is sent to the robot, he will begin asking the kids to find one of the words in the list. The student looks at the picture cards and can either show him what they found, in which case he will let them know whether it was the card he was looking for, or sometimes the student will not show him anything at all, also okay. The robot will politely let them know he did not see anything and ask them to find the picture that matches the word he asked for. When the correct picture is shown, the robot makes a random congratulatory sound and movement. When incorrect, he encourages them for the next time. We have seen firsthand the impact of this action. It is really rewarding for everybody involved. The promise of social robot technology is amazing, but for many of the teachers, realizing it on a day-to-day basis can be extremely taxing. To accomplish many of the desired behaviors, teachers must have time, but their focus and expertise is working and helping kids, not programming. Asking teachers to program their desired complex behaviors to help their students has proven frustrating and very unsuccessful. I know this because I went to a robotics conference. I met many instructors who saw value in these social robots, but didn't know how to use them. Many of the robots ended up on shelves. So, how do we get the robots off the shelves and back into the classroom? The best way would be to create a program that is modifiable, easy to use, flexible, and quick like a bunny. Secondly, the content needs to be adaptable for each student's IEPs or individual education program needs, offering global content that is applicable to any geographic region or area. Our world is shrinking and content is becoming universal, which means concepts remain constant. An apple is an apple no matter where you are in the world. It might be red, green, or sliced, but it's still an apple. Our third challenge was to configure seamless communication to and from the robot. This proved to be a challenge and required many of the available tools within the FileMaker Workplace Innovation Platform, which we will dive into later in the presentation. And finally, we needed to give meaningful feedback by retrieving and tracking the results for teachers, administrators, parents, and other authorized personnel. Ultimately, existing technologies for setting up behaviors in the social robots requires more of an investment in time and skill than is practical or attractive to non-programmers, which left many teachers stuck in the work rut. As a programmer, I love to write Python, JavaScript, and XML. This is just not the case for the majority of these teachers. And even if they do enjoy programming, the time needed is not available for them during the day. This became clearly evident after meeting and working with a special education teacher in New Jersey. Meet Mary Ellen, a certified speech and language specialist in the state of New Jersey. She's focused much of her work in early education, providing communication services to special needs students, many on the autism spectrum. Always looking to improve communication skills, she's an advocate for collaboration with her colleagues and learning new techniques for therapy. When approached in 2013 to include a humanoid robot as a teaching tool, she was skeptical but willing. In winter 2017, Mary Ellen was introduced to me. She had a myriad of frustrations and was ready to stop using the robots altogether. She reached out to several now robot vendors, and through this, we were connected. After talking with her and understanding her needs, we came up with a plan as something was needed that had the capability to create customizable programs for social robots quickly and easily if they were going to continue to use them. But at this point, Mary Ellen needed some success stories. So we developed several standalone behaviors for her to test and for us to get feedback on. We had weekly phone calls to discuss what was working, what she needed next, and what we could do to help. Once Mary Ellen had a few working behaviors, she was able to give us even more feedback regarding guidelines for behaviors, and more importantly, modifiable parameters that would be beneficial. The kids liked the activities and got to see more of their beloved robots, Harry and Peter. Mary Ellen has embraced using a Now robot as an educational aid while working with her students and is looking for new programs to expand communication possibilities. Currently, Now is used with individual students, whole classes, and within individualized speech and language sessions. Now, in order to solve the work with a fully functional application, the solution would require integration with the Internet of Things and the Internet of Robotic Things. Let's pause here for a moment to dive into those terms for those unfamiliar with them. The Internet of Things, IoT, as defined by Wikipedia, is a network of devices, vehicles, and home appliances that contain electronics, software, actuators, and connectivity, which allows these things to connect, interact, and exchange data. iPads, 3D printers, and smartboards are all examples of IoT devices that may be used in a classroom. IoT involves extending internet connectivity beyond standard devices, such as desktops, laptops, smartphones, and tablets, to any range of traditionally dumb or non-internet enabled physical devices and everyday objects. Embedded with technology, these devices can communicate and interact over the internet, and they can be remotely monitored and controlled. When we align the same core technologies that drive IoT, cloud computing, big data, sensors, control systems, to robotics, we get what has been coined as the Internet of Robotic Things, or IORT. They are not just passive like an IoT object such as the Nest. They really do something to manipulate the environment. For those who are unfamiliar with the product, the Nest is connecting the home. For example, lock or unlock the doors or change the thermostat. One example of an IORT device that you may be familiar with is telepresence robots such as Vigo and Beam. They're used for kids that aren't able to be in the classroom, allowing them to attend school. In IORT, robotic products are connected to the internet and are able to identify themselves to other devices. The IORT can bring together people, robots, data, and processes to achieve better outcomes efficiently. The ARIES project is a FileMaker system performing two tasks: tracking student activities with the robots and managing the behaviors on the robots, generating the behavior code, sending it to a robot, and collecting it back from the robot. The two functions require two kinds of programming. The first being what we typically think of for a FileMaker system: tables, fields, scripting, graphs, reports. And the second is creating code for an environment outside of FileMaker: Python, JavaScript, curl, JSON, and XML, and using non-FileMaker programming within FileMaker, JavaScript and web viewers, for example. We wanted to create an interface that could generate modifiable behaviors, communicate directly with the robot, retrieve the results from the robot to begin displaying and analyzing results, and integrate with the IORT API. In order to innovate the workplace, in this case, Mary Ellen's school, communicating with the IORT device needed to take place in the interface, including but not limited to starting the behavior, having the robot say something to the student. For example, "Wilma, do you see the beautiful flower out our window today?" Have the robot sit down, stand up, walk, talk, and go to rest. So first, let's take a look at the interface that we are developing to face these challenges. The following screenshots of ARIES are from the desktop version. The iOS version is designed for smaller screens. We needed to decide how to present the information to the teacher or therapist in such a fashion that they could create their custom behaviors. Most of the time, this learning opportunity is taking place with the child or children sitting right next to them. We learned that many times it was difficult to prepare the behaviors ahead of time due to the nature of working with special needs children. So we needed to make sure that the interface was tailored to be adaptable on the fly and that the communication to the IORT device, the robot, was seamless. Once the behavior was selected and modified, it needed to be wirelessly sent to the robot and then the results retrieved from the robot. Flexibility is key. Many kids with autism suffer from sensory issues. So anything perceived uncomfortable clothing, a light that is flickering nearby, or an unusual smell could cause the need for a quick adjustment to the days of lesson plan. I know from my own experience with my own special needs granddaughter how important this flexibility is needed. One of the many strengths that the FileMaker platform has afforded us is the ability to build custom dashboards with meaningful data. The screenshot we're viewing is our Aries project main menu or dashboard. It includes information such as students scheduled for the current day, behaviors ready to play and retrieve, quick access to songs and stories that can be used in a group setting, and also simple behaviors for the robot such as sitting, standing, saying a custom message sent from the interface. One of the most important features on this page, though, is the data analysis, which allows for instructors to see overall strengths and weaknesses. It is very straightforward to move from the dashboard to an individual student to start a new behavior. Once a student has been selected, it brings us to the workspace for that student. From this page, behaviors can be created and executed, data is retrieved, and student progress is tracked. For example, this is a vocabulary behavior. The teacher can decide how many tries the student may need for the current set of words, select which robot will be used, and then choose a category and the words desired. Several categories can be selected. This example is using multiple categories: clothing, animals, colors, and actions with corresponding words in each category. Once the results are retrieved from the robot, the detail is shown, the number of tries, whether or not the child succeeded, and we have given the teacher the ability to override. This would be used if the robot didn't see something correctly. Remember, we're working with robots and kids. The panel on the left shows behaviors that have both been run and not run. There are several interactive components. FileMaker's Workplace Innovation Platform offers several tools, including new windows, tooltips, sliding tabs that all make the UX or user experience effective and enjoyable. Let's take a look at the vocabulary behavior in action.
Hello. Today we are going to work on vocabulary words together. Sheep. Yay! You found it. You showed sheep. Excellent work. Find horse. Yay! You found it. You showed horse. Hey! Yeah! Yay! You did it.
If the duplicate button is clicked while in a student's workspace, Mary Ellen can assign the same behavior to one or more students. Using FileMaker's popover button feature and card windows ensure that Mary Ellen can keep her focus on the current student while preparing behaviors for additional students. After the behavior has been duplicated to other students, Mary Ellen still has the ability to modify based on each student's needs. The reason that Mary Ellen likes the duplicate feature is that when she's working on a concept, such as, let's say, spring, she can set up a vocabulary template with categories like animals, clothing, and actions, and focus on words such as chicks, bunnies, planting, umbrella, and raincoat that are associated with the concept of spring. Let's take a moment to dive into how we're using XML, Python, and curl options within FileMaker to generate and send the behavior to the robot. We store an XML document that is used to prepare the behavior for the robot. This code includes XML, Python, and strings calculated in FileMaker. Then we're using FileMaker functions to build the path and the curl options for the insert from URL script step to communicate with the robot. Because Mary Ellen is able to see the results of past attempts, she's better able to decide how to proceed quickly and easily. The documentation for assessment is an essential component for the IEP, Individual Education Program, monitoring. So collecting reliable data from the activities performed with the robot is paramount. If the data retrieved is not reliable and accurate, then the teacher is trying to manually record the results, which once again makes using the IORT less attractive as a learning tool. We have gone to great lengths to ensure that the data retrieved is valid. We'll explore some of the technologies used for data retrieval in the coming slides. The graph shown here displays the results of completed behaviors, which give a snapshot of a student's mastered skills and learning opportunities. By giving the teacher the ability to make decisions through visualization of patterns, for example, finding bread, is problematic for this child. It allows the instructor to steer processes in a more meaningful way by adding these words to additional behaviors. Mary Ellen has indicated that it can take many weeks to many months to master some words. The graph that we looked at previously is using FileMaker's web viewer, allowing the instructor to focus on specific results. We are also using the web viewer to run JavaScript that sends commands to the robot, including running the behavior. So we are actually communicating with the robot using two different FileMaker tools, the web viewer and the insert from URL script step. Now, we've seen some of the languages used in this interface. Let's talk about the technology. We have a cloud-based data warehouse where data is stored. We'll be using machine learning algorithms to show student, school, and global statistics. Machine learning is a method of data analysis that automates analytical model building. It's a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Cool. Let's talk a bit about how we are using some of these languages within the FileMaker Workplace Innovation Platform. First, JavaScript is used with the FileMaker web viewer to create an on-demand connection to our IORT device. This enables our users to get the robot to run, start, stop, sit down, stand up, and wake up. Our buttons on the previous layout are using JavaScript, CSS, HTML, and current data from the interface, all using native FileMaker technologies. Next, JSON and curl are used to communicate with APIs, including but not limited to the Now Key Robot Operating System by SoftBank Robotics, Google Talk, Google Dialog, and Watson. For example, we can build a conversation on any subject within Google Dialog, and we get the benefit of thousands, if not millions, of other people's input based off of our key phrases. We can still maintain the integrity of the conversation, but it will have the benefit of a much wider knowledge base. Furthermore, FTP and SCP are used by FileMaker's insert from URL script step to move data and behavior files to and from the IORT device, the robot, seamlessly. And finally, Python is one of the primary languages we use for developing the functionality of the behavior, and XML is used extensively once the behavior has been defined. FileMaker is great at writing XML. These files are constructed using scripting, substitutions, and calculations in FileMaker, subsequently creating a new custom document or behavior for each action that is sent to the robot for use. Let's take a quick look at this environment in action.
Hello. Today we are going to practice some movements together. Do this. Spectacular work. Copy me. Sensational.
We developed this gross motor imitation skills behavior for Mary Ellen. A few weeks after she started using it, I received an emotional phone call in the middle of an afternoon on a weekday. Very unusual. There was a young boy who had very limited interaction skills and did not respond well or not at all to tasks. Well, This little boy performed all 10 motor imitation skill movements that Harry the robot asked him to do it, and the first time, for the first time. It was quite a call. Some of the key benefits that have transpired because of the ARIES project are now that Mary Ellen now has 17 sessions a week, up from 3 per week last year, giving more opportunities to use the IORT. Each session is being tailored to the student's specific goals by the behaviors being modifiable and having the flexibility to update while the student is sitting next to them. The ability to customize the child's session and send the behavior to the robot in seconds has made it possible for her to wait until she sees the child to make decisions. Again, one of the challenges Mary Ellen faces is that until the child or children come to her, she may not know exactly what behavior or activity will be most beneficial that day. The excitement of seeing data collection and reporting available through the ARIES project interface has surpassed Mary Ellen's expectations, and the data visualization from the collection is allowing for faster decision-making and implementation. Using the FileMaker Workplace Innovation Platform has allowed us to develop methods to seamlessly communicate with the IORT device. One final benefit I want to mention is that Mary Ellen can now use the robot for longer periods with each student, and the students have easy access to activities and reward behaviors, songs, games, and stories. I've mentioned a number of features and functions that we've used in the FileMaker Workplace Innovation Platform. Now I want to reiterate why we chose FileMaker as the best tool for the ARIES project. So why didn't we just build a website? First, many schools have little or no reliable connectivity to the internet. Don't get me wrong, we do need Wi-Fi to complete the process at some point. The benefits of using social robots in the classroom meant that we needed a robust development platform for teachers to use while not worrying about connectivity or usability. The user experience was paramount in our decision to use FileMaker. The FileMaker platform of Pro, Go, WebDirect, and Server offers the flexibility to use all of the mediums based on our project specifications. FileMaker Pro and Go are where we developed our flagship application. WebDirect is used for reporting access for parents, administrators, and other authorized personnel. Side note, we're using strong encryption for all data collection and information sharing. FileMaker is instrumental in this configuration. FileMaker Server is instrumental. Several servers set up in strategic locations will be processing and tracking interface updates. Global data collection using SSL stored in our cloud-based data store, giving us the opportunity to share results using machine learning. FileMaker makes it possible to directly communicate with IoT and IORT devices, allowing us to send and retrieve information, giving real-time accurate feedback. Furthermore, a multitude of programming languages, including Curl, JSON, Python, XML, FTP, and SCP, as well as connecting to APIs when using FileMaker, makes it an ideal tool for the ARIES project. Many IORT devices require the use of several languages to develop for and communicate with. FileMaker Innovation Platform is a perfect tool for this project. So planning for the future for the ARIES project not only includes expanding our ongoing initial challenge of creating global content, it's a never-ending programming process, and we have an entire wall of projects waiting to be added to our available list of programs. On the flip side, besides the alarming number of kids diagnosed with autism each year, patients with dementia or Alzheimer's are also a target audience for the ARIES project. These same social robots have been shown to benefit both groups using many of the same processes, including using a chatbot for conversation and information sharing, talking to them, exercising, and memory retention. Many of these people still need to know what an apple is. For example, the social robot can share the current weather, the day of the week, while a caregiver can have the robot ask questions that maybe the patient does not want to discuss directly with family members or staff. So next on the list will be to integrate a chatbot to fully utilize Google Dialog and/or Watson AI artificial intelligence capabilities. The possibilities are endless with the FileMaker Workplace Innovation Platform and the ARIES project. We are just beginning. I'd like to thank everyone for your time. Now I'd like to hand it back over to Rick for some final words.
Thank you, Bonnie. On the next slide, you're going to see a number of resources. First off, the FileMaker community. It's an excellent resource for discussions and networking. There's thousands of FileMaker developers and users there. You can search for IoT, for example, and it'll show you blogs and video posts of how our partners are developing in this area if you want some additional information. Also available in the community are the DevCon 2018 integration tracks. There's 9 video sessions from FileMaker experts that cover the FileMaker Data API, web services integration, using REST in FileMaker, curl and JSON, and additional technologies. The FileMaker Data API guide is available in the FileMaker website and provides steps for integration with REST API services. And then finally, you can contact Bonnie. You see her contact information here at the bottom of the slide with questions about the exciting work that she's doing with FileMaker and robotics. So at this time, we'll go into Q&A session. So remember, if you have any questions whatsoever, just feel free to enter them here, and we'll try to get to those. So at this point, Robert, is there any questions for Bonnie or ourselves here?
Sure. So Bonnie, this first one's for you. How long did the project take, starting from planning all the way to your actual deployment?
Gosh, that's kind of a tough one. I started on this project 4 years ago with a dream, and there's a lot in robotics to learn. So a lot of the time spent was actually the robotics side of it. We've been working on it constantly for the last 12 months, and it's been a lot of work depending on which side of the coin we're working on. So it's taken us about a year to do the actual work.
All right. We don't have excuse me, very many questions coming in so far. Oh, here's one for Bonnie. What version of the robot are you working with?
We use a V5 and a V6.
Great.
Works with both.
This isn't a question, but just a comment for you, Bonnie. It sounds like people think it was an excellent presentation and that you did a fantastic job, which I wholeheartedly agree with.
Thank you.
I have a question here as well about, can you talk more about how you're integrating or working or exchanging between the FileMaker platform and Python, and a little bit more about, I'm assuming that the Python is the language that communicates natively to the robot?
Well, actually, yeah, Python is what we do a lot of the writing in Python, and that's one of our choices. It's an XML document that we're working with in the end that's what's doing the actual final communication. It's building the structure. So as we know, XML does quite so well. So we actually store all of that part of it. Once the Python has been written and we've done what we want to do with the robot for the behavior, then we go all totally FileMaker. And that's where we store our database information and anything that needs to be modified in the XML document that's being sent to him, which includes the Python. So at that point, we're storing it in there. We fix the XML document, and then we send that using the insert from URL to the robot, and it's stored there, and that's how it's played. So it sits on the robot just briefly while it's being played, which is kind of one of the good things. When these teachers that we've been working with over the last year, one of the things we talked about was internet connectivity in the classroom, which is marginal in so many schools. So once they get their stuff on the robot, their programs on the robot, we have a couple of buttons on there for them: Aries Play, Aries Games, Aries Songs, and they can have that ready to go, and they don't need anything else but the robot at that point. We store the results on the robot, and when they get back to the classroom, they can retrieve everything, so we can build our statistical data.
Interesting. Robert, additional questions?
Yeah, we've got a bunch coming in now. So Bonnie, here's one. What alliances are you forging with academic centers providing master's and PhD programs and teaching children with special needs, programs like the one at the University of Virginia?
I'm not familiar with that one, but we are forging one. We have a group in Montreal right now that we're working with. We're doing a test of them beginning in January, and they are PhD students working there. So we're interested in working with any others that would be willing to use our product in there. and test it and use it to find out, give us more feedback. We need as much feedback as we can from the kids and the teachers, well, not from the kids, but from the teachers using them on what they're building for the kids. So we have one school, the school that we had worked on this for, and then we did we have the location in Montreal, which is not at a school. It's a PhD candidate who's doing that part. So if you're interested, just contact me.
Perfect. So here's another one. This is maybe an easy one. How much did the robots cost?
They're been on the pricey side. They range in the $9,000, $10,000 range. And just FYI, out of the box, they do nothing. They turn on. There you go.
And where do you store this data, and how do you distribute it across different schools?
It'll be in our cloud-based data store. Now, that's only for the retrieval of the results is all we're really working with at that point. The data is stored locally for them on their own machines. That way they can control what they're doing, they can build their own behaviors, they can do anything they want at that point. We really had to stay away from requiring them to be online all the time. And so what we're storing on our cloud data will be our updates that we're sending them when we have a new behaviors, which come out quarterly. And then we're also storing the results, and that's where we'll start doing more of our analyzation and sending that back to them. So they'll be getting stuff back from us on that and the benefit of a wider group. So we'll be using cloud-based storage service throughout just various locations. We're trying to spread the load a little bit.
Great. What was the most challenging aspect of this project, e.g. cloud to bot or connecting to Google Talk or AI?
The most challenging pieces, there were two of them. And the first one I'll say is connecting to the robot and getting that piece built. And it turned out to be such a simple fix. It just kind of makes me laugh when I think about it now. But literally, at the conferences, at FileMaker Developer conferences, I think I must have talked to 1,000 people over the years, and I'm sure they were so tired of me talking to them about this particular issue. But yeah, that was probably the most difficult, was building that connection. And the other was using command lines and insert from a URL and bypassing passwords. That was, and using that so that we could connect to the robot, so we're not asking teachers to type in passwords, which we couldn't have. That was a huge challenging. Catherine and I spent many, many hours working on that. I talked to a lot of engineers about that one too, but we got it. We've got the technology, and again, it was probably staring us in the face. We just didn't see it.
By the way, I see a number of people in here expressing interest in further information or applying it to their particular field. And so I'd encourage you for these to just reach out directly to Bonnie on this, and she can either steer you in the right place or, but it sounds like you sort of sparked some imagination here about other applications, Bonnie. So I think that's good to see.
That's great. Yeah.
Robert, other questions?
Yeah, so from your experience, what's an effective way to let educators use this technology for both the FileMaker and the robot in the classroom?
From my experience, to use this easily, right now, we're just going to be using FileMaker in the classroom. I guess I'm not sure what the question is. Can you repeat it one more time for me?
Sure. So from your experience, what is an effective way to let educators use the technology? I guess speak to, how they're interacting with it on their side within inside of the classroom.
Okay.
Sounds like what the question is.
Currently, there's lots of robots in schools right now. A ton of these guys in the schools in the United States, Canada, Australia. Europe has had them much longer than we have over here in North America. But we've got a lot of them, hundreds of them, hundreds of them, and many of them are sitting in boxes because the teachers thought they could do it, but they just simply don't have time. So from our standpoint, we can give them the tools so that they can do, for starters, the autism stuff. But we also have stories and songs that they're using in mainstream classrooms. They're using them there. Libraries are another good place that they can be used. And then they can get results back if it's appropriate. They don't all have to get results back. Sometimes they just want to use it for, because it's different. It's another way for the kids to learn. They form an emotional attachment to their robots. Like I talked about Harry and Peter with the kids in New Jersey. They love Harry and Peter, and they were kind of getting frustrated because they didn't have enough to do with them. Well, and now they do, and they get stuff new all the time. They love hearing them tell stories and walk and talk and sing a song, or do their school song. We just did one of those for somebody, where the robots are doing the movements with them and the kids are doing the school song. So they can integrate it in a lot of different ways. Those are just a couple of the ways. I've been approached by science teachers who say, well, maybe we can do this with them. People can get very creative, but mostly what they needed an interface, something that could connect to the robot that gave them an easier way to put the behavior of what they wanted and get it over to the robot so they could get it running without spending the time that we do. And as programmers, we can knock it out pretty fast, but teachers, they don't have the time. They have an hour planning period, and pretty much that's it. And you're not going to program much in an hour.
Yep. There's a number of questions here asking for your contact information. So what we'll be doing is, for everyone that was registered for this event, we'll send out a follow-up email. We'll have your contact information as well as the resources that are available, so that they have that. But I'm really sort of pleasantly surprised to see the level of interest in this and all of the other applications. It seems I'm pleasantly surprised, to tell you the truth, that there's this much interest, because I think people sort of can get it. One of the questions here that's intriguing, they said, someone asked, what social skills do social robots teach?
We, through songs and stories, we teach them. They do emotional type things. They can talk about sad and happy, and they can help them through transitions. They can talk to them about their clothes. They can talk to them about food, talk to them about just speaking. Now, one of the main test groups that we've had over the past year, though, we're working with non-speaking autistic children. So we have a whole different angle on some of that. They probably won't ever speak, and so, but they do still need to learn to sit down, stand up, learn what the different vocabulary words. We do comparisons. We do all types of different other games and stories for them. So the stories all are meaningful and are teaching some skill when we do them. We actually have our own storyline that we're following through with right now, and they all teach a lesson in some sort of, some form or fashion.
So, Bonnie, there also looks like there's a number of questions around foreign languages, where English isn't their first language. Is there any insights you can give there?
Yeah, I can. We have integrated Spanish, French, and Japanese into our solution. Apparently, there's some countries where they're just now getting on board and recognizing the autism, as a condition that they need to address. And so we've been asked to include some other languages. So because we're going to be in Montreal in January, they're doing primarily English speaking, but we're including French as well. So they'll be able to decide which way they want the robot to go. And these robots have many, many languages. I don't even know how many, a lot. And so we'll be doing both of those. We include the languages in there. So far, those are the ones that we have.
Perfect. Specific technical question: what kernel or OS is the robots running?
Yeah, I don't know. It's running a Linux system, and the newest one. I wish I could tell you that. I don't know the answer to that. I could tell somebody, if you email me, I can get you some specifications if you're interested. But it's modified, and so, for instance, here's a good example of where we run into some issues. If we're writing Python, for example, and we go look for that, or we're writing a SQL query, the SQL queries are pretty straightforward for most of us, but we have to modify them slightly many times in our code to go with what the robot's OS is actually handling. So it's something that we're constantly working with when we're doing our straight ahead code of Python and SQL. So.
There's a comment here that I'll just read for those interested. It says, attendees may be interested in a recent article from November 23rd in the New York Times entitled Meet Zora, the Robot Caregiver. They say it's the same robot, but a different group.
Yeah, and actually, that was the very first group that I read about. I had been looking for a robot for many, many years, and most of them were so far out of my range that it wasn't going to happen. And I finally ran across these little Now robots, and they were by Aldebaran out of Paris at that time. And they were the original developers of these Now robots. And the first program that I saw was the Zora project, and they're out of Belgium. Sebastian's a friend of mine. And I love their program, and I love what they're doing to help elderly people, which is one of their main focuses on the Zora program. And the great thing about it is that we complement each other. The Zora program is really designed, it's an easier interface for programming the robot. Say you have a behavior you want to do, and you want to drag and drop some things on the desktop, and you want to have the robot do that. Ours, on the other side, we're giving them all the programs, and we're letting them modify to their own needs. So they're very complementary. And that program, I mean, Zora's been around for quite a long time. They were written originally by SoftBank, by Aldebaran, now SoftBank.
Here's another one, Bonnie. Can you explain in a little bit more detail the connection that you're making with Google, Watson, and AI?
Right. We can do it both from the robot directly and from FileMaker directly. So right now I've done it both ways, but I just use the API, and I build conversations, around things that are interesting to people and things that might be interesting. It actually goes much further, which I probably don't have time to go into this entire conversation right now, but we will use it mostly for conversational skills. Working with the Alzheimer's and dementia patients, that's a big thing with them right now. Just any type of conversation, talking to them about their kids, the weather, what's going on today. In the program that you just referred to, where they have all the experience, they've been using it where we watch the robots. I can have somebody sit down the hall, and the robot can walk down the hall by himself, and I can go down there, and I know that Mrs. Jones really doesn't want to tell her doctor that her stomach hurts, but we can ask her about that, and they will just talk to these little robots because they're so darn cute. And they sound great, and they are very approachable, and people tend to talk to them. We have so many tools at our disposal built into the API on the robot, and because of our connection using insert from URL, we can, and FTP, we use both STP, STP, insert from URL, all of those. We can bring information back into FileMaker as well and store it and do many more things with it so that we can gather real data for real analysis.
Bonnie, I think we're getting close to the end here, but I have a question regarding with the use of AI and machine learning, does the robot get smarter over time, or do you still have to program everything that it does?
They only get, just like anything else, they only get smarter over time with the connectivity that we give and the access that we give them. So when we're with Google Dialog or Google Talk or Watson, we're putting in key phrases. So we're building a conversation. Then when I submit it, I get information back from them. So I use my key phrases to control the conversation. Especially when I'm working with kids, I want to very much, I want to control it regardless, but you want to find out what's going on, but I can put in information. So they get smarter only because of the programming that we put into them and the options that we give them where they can go and look for information. So I don't have to do it again. I have one that talks about propane, and he loves to talk about propane, and he has a nice conversation, and everybody's conversation is slightly different when they ask the same questions. He'll direct them a little differently in the conversation. But that was programming that we put in there to give him options.
All right, great. Thanks so much. There's a lot of interest here. I'm assuming you're going to be hearing from people for a while on this. I do believe that the recording will be posted to the community for those that have asked that question. And they'll be interested to hear back from you, Bonnie, over the next few weeks, sort of what came out of this. But thank you so much for doing this. Also like to thank everyone who spent their time from their busy day to pay attention to this very interesting topic and convergence of FileMaker on these cutting edge technologies that we have available to us now directly within our platform. And so thank you, Bonnie.
Thank you. It's great.